Hi, this is Tim Kelly. I'm the Senior Product Manager with Autodesk Tandem, and today we'll be talking about Autodesk Tandem and how we leverage BIM workflows to realize digital twins. Quickly before we get started, because I'll be sharing future development plans with you today, and those plans may change over time, purchasing decisions should not be made based on this presentation. Quick agenda today, we'll talk about digital twins, the opportunities and challenges in the market. Specifically, our focus on digital handover workflows, starting digital, staying digital, and delivering digital through the AEC lifecycle. Shifting into operations and how we think about connected buildings and transforming data into actionable insights. And then we'll wrap up with a couple of quick items around demo of the product, roadmap, and some structures around our APIs and business model. Stepping into digital twin and the overall landscape in the industry, we'll quickly start with a definition of digital twin from an Autodesk perspective, and that is a digital replica of a built asset, and that possesses a dynamic digital reflection of a physical self or a physical facility. It possesses the operational behavioral awareness necessary to simulate, predict, and inform decisions based on real-world conditions. Ultimately, what we're looking to do is provide an appropriate data structure and leverage that data structure to query information related to the operational workflows and information leveraged during that life cycle. As we think about a digital twin, they ultimately possess the opportunity to transform the built asset lifecycle. With this, we can effectively transform that by tracking a digital thread of information that links various silos of data today, and ultimately connects that operational data from an end-to-end digital process spanning capital planning, architecture and engineering, construction, and ultimately asset management. By connecting through this digital thread, we think about the history of any given asset, space, or system within a facility and how we can leverage that history to drill into specific analytics, provide insights, and ultimately think about the process of leveraging this information across an entire portfolio or capital program to improve the overall performance. With that in mind, we think about things like, is my facility achieving sustainability goals that I have set in place? And if not, what can I do to correct my course? For particular systems, equipment, or material, are they performing based on the specified performance, and if not, are there other components similar or like in my overall portfolio? And what can I do to really future-proof any planning and ultimately optimize my ROI as I think about hitting my goals across a portfolio? As we started the Tandem incubation project, we looked across the industry for different information about how digital twins are leveraged and where the industry is with the adoption of digital twin technology. During that research, we came across an article, a paper published by Predictive about the digital twin ecosystem in the built environment. And leveraging this maturity model, we've organized our roadmap and the way we think about the transition within the industry, leveraging a product like Tandem, and how you go from a traditional deliverable that you might have today to a more comprehensive deliverable in that digital twin ecosystem. To start, Descriptive digital twin possesses the as-built information related to the facility, coming from design and construction information. And this is a collection of data that's captured through that design and construction workflow, and ultimately provided as part of that digital handover, that as-built documentation. It is an editable version of that information, and ultimately you have the ability to maintain that through the life of the asset. It simply needs to be a collection of models that contain the assets or equipment, the spaces, the systems that are associated, and then you have the ability to manage the asset information requirement structure within that construct. As we step up to informative twins, this begins to incorporate sensor information, IoT devices, and other connected components that bring in operational data, time series data, or event information, or otherwise, into the digital twin ecosystem, making them a single pane of glass. As we think about leveraging that comprehensive structure between descriptive and informative twins, this steps us into that predictive capability where we can leverage that connected information to generate insights or provide workflows to predict potential failures or issues across your facilities. Stepping further up in the stack, we think about comprehensive twins in a way that allows us to simulate future what-if scenarios. Think about broadly that asset utilization across a portfolio. And then as we think back to that kind of full cycle of an asset, and we think about the optimization and utilization of that while preparing or planning for the next capital program, we would leverage those what-if scenarios to feed that information back into that next facility or that future plan. Lastly, with autonomous twins, this is that full cycle within a facility where, as that fine tuning is happening, as that analysis happens in that comprehensive twin, we're able to take that information, feed that back into the physical building and self-tune or correct things within the facility based on that digital twin interaction. Generally, I'll state that where we are with Tandem today as a product, and as we organize around this, our focus for the first kind of leg of development was squarely on the descriptive twin capabilities. And today our engineering team is focused on informative and predictive, where comprehensive and autonomous for us is further out in the future. Generally, when we think about that descriptive twin and the starting point, we frequently see that owners today receive a stack of unorganized or chaotic documents structured in a way that the construction team or the delivery team handed them over, whether they're physically paper or digital paper in the form of large bound PDF documents that are disorganized and provided on a flash drive or otherwise. Where, as we think about handover in the sense of leveraging industry standards and structuring that data within a digital twin environment, we want to build a repeatable process leveraging them to transition that data into FM solutions or CMMS or otherwise capabilities. And we'd like to see that materialized within the digital twin ecosystem, where today it generally is not. At handover, those mountains of documents are insurmountable or ultimately provide challenges in terms of operational readiness and leveraging that information from day one. Typically, this is with a lack of transparency and provides poor insights into the asset performance for a long period of time until they can get up and running with that information. With Tandem, we specifically set out an objective to create a solution organized around three key principles. First of which is accelerating operational readiness by starting with the end in mind, harnessing the BIM process to provide that digital handover, and create that digital twin. As we shift into operations, we think about connecting to those operational ecosystem capabilities or tools that exist today, and improve efficiency and ultimately improve the occupant experience by leveraging that reflection of your asset spaces and systems, or ultimately that asset information model structure. And then longer term, we expect to optimize portfolio performance by ultimately leveraging that analytical capability of a digital twin to inform future investments and ultimately drive further success with the utilization of digital twins. So over the course of the past 18 months or so, our team has been focused pretty exclusively on that digital handover scenario. The way we think about this is start digital, stay digital, and deliver digital. If we think about making a digital twin in today's collection of tools or in today's world, frequently this is a very bespoke process. And with this digital handover capability and working with an existing BIM procedure, we would expect that a digital twin becomes a highly repeatable natural output from project lifecycle. So in Tandem, it all starts with specifying the asset information requirements of the digital twin. And the first step is actually defining the asset breakdown structure and ultimately organizing that based on either a standard classification system, such as a master format, uniformat, or uniclass structure. And those are typically how you're organizing design and construction specifications in today's world within the delivery phase. Or that can be structured based on a custom classification system based on specifically the client's needs or possibly even a legacy CMMS or IWMS solution. Second, we're leveraging and extending a data dictionary or a set of parameters as a library that defines what needs to be managed within the digital twin. This can include simple values such as a installer's name or manufacturer's name, document links such as a connection to a warranty document or an O&M manual, or ultimately outcomes or specific values or metrics that you'd like to include with a given asset. With this, standards such as COBie or Building Smart Data Dictionary can be leveraged and structured in a way within Tandem that provides a foundation for those delivery requirements. And lastly, you can, within our facility template process, organize multiple templates that apply to multiple different constructs, allowing your team to deliver against specific facility templates, either for specific clients or specific building types that they can leverage again and again. Note that each of these constructs are reusable across facilities, and we also revision or version each classification system, each parameter, and each facility template, allowing you to deploy them over a period of time with multiple versions in given facilities as appropriate. What you're going to see here in the properties panel, this is a screenshot from within Autodesk Tandem, where a component has been defined by its classification, and based on that definition, you're going to see the required data populated within its property set, and allowing then your delivery team or the data capture team to collect that information. As we think about that data capture, we ultimately expect this to be a broad funnel of information coming from a broad delivery team, and ultimately meeting the needs of a broader use case or utilization team that's spread across potentially facilities management, space planning, and operational workflows. When we think about this structure within Tandem, it starts with that design intent, and it begins to build upon the as-built information and the commissioning data. And ultimately, as we think about verifying completeness of an asset, a space, or a system, we think about the requirements that were specified and how we ultimately go about capturing this through that delivery phase to ensure that that digital handover workflow is comprehensive. So within Tandem, we do start with the foundation of BIM, or ultimately a collection of Revit or IFC models today. And we support those formats and expect to expand in the future, but that is going to provide the foundation of how we structure additional information. As we think about capturing documentation or data, we ultimately interact with our common data environment, Autodesk Docs, and from there, BIM Collaborate, or BIM Collaborate Pro. And then lastly, as we think about capturing that installation and commissioning data, we have Exchange with Excel and the ability to interact either directly within Excel with that Tandem data, or an export-import process to and from Excel. And then also with Autodesk Build, or that ACC ecosystem, if you're familiar with Autodesk Construction Cloud, where we would allow for asset capture to be within one of those mobile modules, capturing that field data and bringing that into Tandem. Once all of this is structured and brought into Tandem, we do keep a comprehensive history of all of those edits and contributions that are made over that collection period, and ultimately we'll leverage that in the future as we think about analysis provided on top of Tandem. As I previously mentioned, that structure of an asset information model is this description or association of assets to spaces and systems, or the relationship between assets, spaces, and systems. And within a given facility, this is important when we think about connecting to downstream operational systems like IoT devices, or ultimately digital twin ecosystem solutions such as Microsoft Azure, where it's important that we understand the ontology and the relationships between these things so that I can ultimately drill into a specific building graph and navigate upstream or downstream within a system when a space is too hot or too cold, and I need to understand potentially the impact from failing equipment or otherwise. With a building ontology, we're able to define that in an automated way And with Tandem, we're working toward direct association and automation and how we think about assets associated to a space they're located within, and then ultimately the connection across the system and how those things are connected and our users can navigate within that system to understand that relationship. So as we work to structure that descriptive digital twin as a foundation, this then shifts into how we we'll put in the next coming months our focus into defining connected operational solutions and how we incorporate data from those operational systems into Tandem. So far we've talked about that context, and now we'll look at the connections made to drive digital twin use cases. So within Tandem, we'll ultimately create these connections by linking our asset spaces or systems to operational data. We don't intend to replace existing operational systems or build our own IoT platform. Ultimately, we would expect to make connections to those existing solutions and open up or expose the Tandem information through a broader API, broader interaction in that sense. With that in mind, we will work with popular maintenance management systems, building management ecosystems, IoT devices, and other operational data sets. And through these connections, we'll bring in real-time and historic information of that operational data, and we'll deliver that in a single pane of glass for monitoring and operating your facility. Our goal with this is creating an informative twin by correlating these discrete data silos and leveraging that in context to create actionable insights. With this in mind, last fall, Autodesk established a partner with iOffice SpaceIQ, which you may have heard through recent announcements. But for customers of their solutions, we'd expect to build workflows with these directly and work with this partner to offer an integrated maintenance and space management solution through that Tandem experience. And then lastly, as we think about moving further into the future, with Autodesk Tandem, we'll leverage that data to begin creating or enabling predictive twin, and that predictive capability set allows for analysis of desired outcomes against actual maintenance events and facility performance, and ultimately where Autodesk Tandem will be able to report against that asset or space or system and how it's performing against expectations, whether it's better than expected or worse than expected, and then from there allow our users to drill in and look at corrective course of action to improve that facility performance. To quickly wrap up, we'll step through a really quick demo and then our roadmap discussion. So quickly in Tandem, as we think about aggregating information within our ecosystem, it is a collection or federation of models. From there, I can interact with individual components, search through that property data, specifically drill in on components and look at a diagram or otherwise, maintenance manual, et cetera. And then step out to associated equipment or systems and review performance across that system. So as we think about connecting to that operational data, I have the ability to review that information and step through that through a period of time, or ultimately look at the history of that, searching for anomalies and making correlations as we look at that in context. As this information is connected and we have the ability to detect those anomalies, our connections to a maintenance management solution would be triggering or firing off a ticket to ultimately deploy my facilities team to address the appropriate issue. With the last two quick slides, we're going to step through our roadmap and our API structure here. So with Tandem, as I described, our focus over the past has been on this descriptive twin or twin building capabilities around structuring and gathering and ultimately managing your facility data. As we move into the near future, we're thinking about the process and developing on our informative twin, and that's for facility monitoring, simplifying that user experience for operations professionals, and driving to specific interactions with that set of insights. And then lastly, we'll move into that predictive twin capability, where we're thinking about or rolling up data across a portfolio of facilities and providing analytics or insights to drive actions. With this in mind, we have a structure similar for our APIs, where today we offer a set of REST APIs where you can interact directly with the informative twin or that asset information model. In the future, we'll expand with higher level logic with our SDK, and later beyond that, we'll offer Tandem extensions to allow direct interaction with our application. And then quickly to wrap, you can get started with Tandem for free today. If you visit intandem.autodesk.com, contact us, you can sign up for free. Thank you for the time today. Appreciate it.